in Canvas if you wish. We're going to continue this week with a crash course introduction to Java. And we left off with last time with enhanced for loops, which of course necessitates a conversation on arrays and dynamic data types. So that's where we'll continue with starting today here. So Java does support arrays, traditional static arrays. But there's a key difference if you're coming from a C background. There's no malloc. There is a kind of a malloc. Actually, I shouldn't even say static arrays, traditional arrays. Let me go ahead and just truncate it to that. Because it doesn't actually support static arrays. All arrays are allocated on the heap. Remember from last semester when we talked about static arrays are actually allocated on the stack. So that when you return from calling a function, they're wiped away. They're gone. In Java, however, every array is allocated on the heap, so they're all dynamic. But you also don't have malloc, right? Instead of say malloc in C, you use the let me go ahead and code it, a new keyword. All right. So here's the syntax for doing that. I want to create an array of size 10 that holds 10 integers, right? Int ARR is equal to new int array of size 10. There we go, down at the bottom there, right? I provide the name ARR and then the traditional square brackets there, and then I use the new keyword. That's basically like calling malloc. Give me a new array, and then in another bracket here, I'm providing the size of the array that I want. Once I've done that, then I can treat it like any old array, zero-indexed array. So Java has zero indexing, meaning that if I want to set the first one to, say, 42, then I would start at ARR sub 0 is equal to 42. Where would the last one be then? If I want to set the last one equal to 101, what index would the last one be if it's of size 10? 9, right? It's zero index, so it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's always one less, right? However, unlike, so again, there's no malloc, but instead you use the free keyword, new keyword. But there's also, there is no memory management. All right, in other words, no free. Oops, free, there we go. You simply you let the JVM, that's the Java Virtual Machine, handle everything for you, right? So once you're done with that array and you no longer need it, you've computed everything that you're doing on it, and normally you would free it up, say in C. You just let the Java Virtual Machine take care of it for you. The way that it does that is it keeps track of all dynamically allocated memory. And it has a flag on it that says that, oh, there's still a reference to that, so it's not eligible for garbage collection, right? Otherwise, when it goes out of scope and nothing else has a reference to it, nothing else can access it, then it says, okay, well, that's eligible for garbage collection now. And at some point, the garbage collector will run. Don't worry about it. The JVM handles it for you. And it cleans up that memory for you. And it makes it available for the program again, or maybe back to the operating system, depending on the garbage collector. There is also no bookkeeping. Right? Remember in C, if you wanted to pass an array to a function, you also had to pass the size of that array because there was no way to determine the size of an array in C, a reliable way to do that. In Java, however, that's fixed. Right? Instead, you can always access the size of an array using the .length property. Again, let's go ahead and go into code mode here and do an example. In fact, I'm just going to pull the example from last time down here. Let's see, where is it? Yeah, let's go ahead and cut and paste this. You can also have the declaration style that I did last time. Come on, there we go. All right. Where you don't provide the size of the array. Remember, that's called elision. Let me go ahead and get rid of the lights up here. All right. When something is not necessary, compilers are stupid. Whoa, I didn't mean all of them down. Just the stage. There we go. Sorry about that. I'm not providing the size of this array. Instead, compilers are dumb, but the compiler can count. It can count up however many numbers you've placed inside those curly brackets and determine how big of an array it needs to be. 1, 2, 3, 4, 5, 6, 7, 8. You know what? I don't care. I don't want to count. Right? If I were in C, I would have to count that up and make sure that if I wanted to iterate over that and add them all up, I would have to keep track of that in a separate variable. But in Java, I don't have to do that. Instead, let's go ahead and create a total here. I'm going to sum those up. What is the sum of all of those prime numbers? I'm going to go ahead and go into a traditional for loop here, running from 0. I is less than. Now here's where the size comes in of that array. Again, normally it would be in a separate variable, but now I can go with primes.length, right? And that tells me how big it is. Right? I don't need to do the bookkeeping anymore. The bookkeeping is done for me. I++, and then inside total plus equals primes sub I, right? And it's as simple as that. You don't have to do bookkeeping. You don't have to do memory management. It's a lot easier to do in Java, right? You can also create create arrays of any type, right? So if you want to, you can create an array of doubles, say, double values is equal to, I don't know, new double 100. 100, there at most one, or exactly 100 doubles are contained in that array. If you want to create an array of strings, string names of whatever is equal to new string 5, right? Now, what values are stored in there by default? If this were C, who knows? It completely depends on the compiler, on the operating system, everything. There are default values, however, in Java. What values are stored in values? All zeros. Right? If it's numeric, it's going to be zeros. If it's Boolean, it's going to be false. If it is class types, like string down here, they're all going to be null. We do have null in Java. However, it's all lowercase, right? So if I were to print this out, system.out.print out the first name, right? Let's print out the first one is going to be at 0, right? If I were to print this out, what would it print? Let's find out. I do have Eclipse open here. I just have to bring it over. And let's go with hello world. Oh, no, that's not what I want. There we go. We've been using this hello world code here. Let me go ahead and cut and paste that. What do you think is going to names? Sorry, there we go. What's it going to print? Null. Wait a second. If I tried to do that in C, if I tried to work with null in C, what would eventually happen? It would crash, right, with a segmentation fault. The same thing is going to happen here if I try to screw around with it and try to do something with it. Let me go ahead and just try. I don't know. I can always set it. Names of 0 is equal to Chris. Right? Oops. That's perfectly fine, and that will now print Chris once I save it. Right? But what if I tried? What if I tried to work with it somehow? What if I tried to say, I don't know, names of 0 is equal to, I'm going to go ahead and concatenate whatever was in it before to, I don't know, world. Right? Right? I was under the assumption that it contained hello space, and then I wanted to append on it world. Let's find out what happens here once I save it. Right? So, what happened? How did it interpret this line of code right here? It did an implicit cast of, this is null. How do I represent null as a string? As lowercase null. So it turned it into an actual string instead of null. And then it appended world, and that's why I'm getting null world at the bottom there. Right? You can test for nullity. Right? Instead, let's go ahead and bring it back to the beginning here. If names of 0 is equal to null, and again, it's all lowercase. It is a keyword. We're not talking about the string null anymore. It's a keyword null. And if it's null, then I'll go ahead and print system.out.println no name, right? Or something like that, right? Get rid of that. And when I do this, it'll actually print out both of these things. It'll print out no name and then null on the next line. So you can test for nullity using a simple equality tester, all lowercase. It is not all uppercase like, say, it is in C usually. It's not some camel casing thing. It is all lowercase, N-U-L-L. Okay? So keep that in mind. Let me go ahead and fix this to names, since we saw that that was an issue. All right. So those are arrays, right? Well, I'm going to now discourage you from using them, right? Because being a little bit more modern programming language, Java supports what are called dynamic data structures, which is something that we're going to get into in detail in the later part of this course. We're going to learn about how to implement a linked list, how to implement trees, and other dynamic data structures. Java supports, for example, a list, capital L list, which is a dynamic, zero-indexed. You can treat it like an array. Basically, it's an array that grows or shrinks dynamically as you use it. Right? So the bad thing about using arrays is that they're of a fixed size. That value's up there, that's only going to be 100 doubles. It can't be 99 doubles. If I have more than 100 doubles, I can't suddenly say, okay, I want to fit it in at the end or something like that. That's going to be a static, or it's basically it's a dynamic array, but its size is static. Its size cannot change. It cannot grow dynamically. But lists can. Let me go ahead and show you an example. There are several implementations. We'll just stick with array-based lists or array lists. So let me go ahead and create a list for integers. Right? My list is equal to new array list of integers. Right? And let's talk about the syntax here. I want to, come on. There we go. All right. So we'll get into interfaces and inheritance and stuff like that. Just know that you can use this now. And I think I've got a misspelling there, but that's okay. I'll fix it in a second. This is a list. It holds elements in an order. The first element is at index 0. The second one is at 1. The third one is at 2, et cetera, et cetera. So it holds things in order. What does it hold? It holds integers. This Langle-Wrangle, that is less than and greater than symbol right there, that's a parameterization. That says that this list can only hold integers. If you ever try to make it hold something that's not an integer, that's going to be a compiler error. Let me go ahead and copy this over to my IDE, and we'll see what I'm talking about. We'll go ahead and get rid of this. All right, and integer, there we go. And it's complaining initially because these are not in the standard library. Java.lang is the standard library. So I do need to import them, both the array list and the list. So where are they? They're in this package called java.util. All of the dynamic data structures are going to be in util. Util, short for utilities. Okay? Once I've got this list, I can start adding things to it. MyList.add 10. Right, there we go. MyList.add 20. MyList.add 30. So it keeps an order. If I'm adding to it, I'm adding it to the end. If I wanted to print this list out, system.out.println MyList, there we go. Then the order that I would expect it to be would be 10, 20, and 30, because that's the order that I added them in. Anytime that you use this method add, it adds to the end. There are other methods that you can use, mylist.add. If you can't see it down here, but there are several suggestions. There's add, index-based add. In other words, add it to the list, but at a particular index. There's add all. Given in another collection, you can add them all to the end, or add them, splice them in, and put them in a particular place. I'm just going to add, say, 40, but I'm going to add it at index. I believe index came first. Now I forget. List.add. Yeah, the index is first, so let me add it at index 1. I'll add 40 at index 1. What should it look like now? 10, 20, 30. So index 0, 1, and 2. But if I want to add it here, so 10, 20, 30, I want to add 40 here. What's it going to do? It's not going to replace 20. it's going to shove it down to make room for it. So it'll be 10, 40, if my thinking is correct, 10, 40, 20, 30. Right? So this is a dynamic data structure. You can add stuff in. You don't have to worry about did I ever declare the size? I called new integer array of size 50. No, it grows and it shrinks dynamically as needed. Right? And we'll actually get into it on how this actually works under the hood. But basically, it's a nice artifact of object-oriented programming. You can also remove stuff. MyList.remove. We'll remove it at index, 3. This might cause some problems here. I'll remove the last one, and then we'll print it out and see what happens here. It should be 10, 40, 20. I'm crossing my fingers here because, 10, 40, or what did I say? That's what 10, 40, 20. That's what it should be, right? Because 30 was the last one. So I removed the last one, and I removed the element at index 3. So it was 0, 1, 2, and 3. So it removed the last one. You could do a bunch of other stuff with it. Like, what do I want to do with? What else do I want to do with it? What if I wanted to determine its size? Right? Int n is equal to. Now it's not length, dot length, because it's no longer a regular static, or it's no longer a regular array. So instead, it provides a method to do that. MyList.size. Right? And then I can use that, right? If I wanted to iterate over it and add a 1 to everything, right? Let's go ahead and for int I equals 0, I is less than n, I plus plus. I could have put this in line, so I could have just replaced this and put it right there if I wanted. If I didn't want to store that off as a variable, that's fine too. I can go ahead and system.out.println. Now, how do I get the ith element? Yeah?
How come for a list it's a method, but for an array it's just...
Good question, because an array is technically not an object. Technically, it's kind of in this limbo of being an object or not. In Java, classes have methods. And I do believe that arrays do have kind of pseudo methods, but I forget the exact nomenclature that they attach to that. But with dot length, that's an actual property. We don't have properties with lists, at least. Right? So it's kind of like a variable inside of the array that's stored as kind of metadata. It's just a different way of doing things. It's more consistent to use a method with a list because everything is you access everything through methods. Right? How do I get the? Speaking of which, how do I get the ith element? Well, my list dot get. I want the ith element, right? And I can go ahead and print that out one to a line. Now it'll print out 10, 40, 20, each one to its own line. And then, of course, I left this in so I can print them all out at the end if I want to. Right? So that's just the tip of the iceberg. If you want to take a look at everything that it provides, Java list. Right? All you do is do a quick Google search for it, and you'll see that there are lots of different things that you can do. There are 4 different add methods. There's clear. You can clear it all out, remove everything at once. You can get an element. You can find the index of a particular element. You can determine whether or not it's empty. You can use iterators on it, et cetera, et cetera. You can remove elements. You can replace elements. So set the element at index I to this element instead. In other words, instead of shoving it between and shifting it down and making room for it, it actually takes that element out and replaces it. You can sort it, right? You can dump it to an array if you want to work with a traditional array. But once you see dynamic data structures like this, you're not going to want to go back, right? Once you've seen Paris, you can't go back home. Because these are so much more elegant to use. These are so much more convenient to use. The vast majority of functionality that you want is already built into it. Okay? Let me go ahead and bring it back over here so that we can, that it'll be in the notes when and available when I post them. But that's not all, right? I'm going to show you 2 more data structures like this. You can also use what is called a set, which enforces unique elements, right? So with an array, you can put 10 10s in there. You can put 3 5s in there. You can put duplicates in your array. But with a set, if you don't want duplicates, then you can instead use a set interface. And let me go ahead and go back over here and show you how that works. So instead of a list, I'm going to set this to a set. And a common implementation that I'll show you here is a hash set. Right? And again, it's going to complain about this because I have not imported them. Once I import them, then everything is fine. Where were they? They were in that same java.util package. Right? Everything works except for this one now. Right? I can add 10, I can add 20, I can add 30. But why can I not add an element 40 at index 1? Because a set is unordered. With an array, you have the idea of the first element, the second element, the third element. It's not the same thing as sorting. Right? I could put them in a randomized order, 10, 50, 20, 30, 5. Right? I could put them in whatever order I want. That's not sorting, but they are ordered. There's a first element, a second element, and and a last element. But with a set, there's no ordering. It only contains unique elements, and it doesn't provide an ordering for you. So I can't arbitrarily add an element at any old index because there is no index. I can go ahead and add that if I want, and let me go ahead and print it out and see what it looks like. Let me go ahead and copy this and remove it. There we go. I'll bring it back here in a second. Is that the order that I added them in? Nope. It's the order that it thought best. It's actually using a hash table under the hood. And so it's using some sort of a hash function to store them efficiently. Right? It's storing them in whatever, and it's retrieving them in whatever order it thinks is best and most efficient. Right? You can remove stuff. Of course, does 3 exist in there? Nope. So let me go ahead and remove, 30. And then print it out again. There we go. That's no longer an index-based removal. I actually have to remove 30. And then print it out again. It'll go through, find 30 for me, and then remove it. There's 20, 40, 10, 30. Not the order that I put them in, but when it gets taken out, then it's gone. And by the way, that order is not necessarily maintained. Internally, it could change the ordering on you if it felt that it needed to. You can't read anything into that ordering whatsoever. It's non-deterministic. So what happens when I try to do this? Get the ith element. Well, if it's not ordered, there's no such thing as the ith element because there's no such thing as the first element, third element, etc. So I can no longer use a traditional for loop to do something like this. Instead, what can I use? Remember it from last time? It's the last thing we discussed on Thursday. An enhanced for loop, right? So for each element, for each integer, x, in the collection, my list, and maybe I should no longer call it my list, right? Because it's not a list. Let me go ahead and fix that now. All right, I'm going to have to change it 1, 2, 3, 4, 5, 6, 7, whatever times, right? No. Remember that trick that I showed you. Highlight it, refactor, rename it, my set. And it's renamed everywhere for you, right? So again, highlight, right-click, refactor, where is it? Refactor, rename. And that works pretty much with everything. Right? Now it's my set. I'll remove 30, then I'll print it out. I can iterate over each element, system.out.println x. Right? And it's not going to tell me what the index which it's stored because there is no indexing with a set. So it's an unordered collection that enforces unique elements. And now let me show you how it enforces unique elements. My set.add 10. Oh, not at all, but 10. There we go. So if this were a list, you would have 2 copies of 10 now because I added it up on line 30 and I added it down here on line 38. When I print it out on line 40, though, are there going to be 2 10s there? Nope. There's only ever one 10 because there's only ever one element that matches unique elements, basically. Right? So let me go ahead and cut and paste this and bring it back over so that you have it in the notes as well. Again, a set enforces unique elements, and there is no ordering of elements in a set. Right? Just like mathematically, right? Many of you are probably taking 235 right now, and maybe eventually learning about sets. Sets are unordered collections of unique elements. You don't have duplicates. If you did have that, then you'd have multi-sets. And it's unordered, right? Traditionally, you write them in order, but that's because we're humans and we love order. It feels weird to write it down as 20, 10, 30, and 5, right? That's just weird. Rewrite that so that it's in order. Set, however, does not necessarily have any particular ordering. Right? The third and final dynamic data structure that I want to show you are maps. Oh, you say what? Oh, yeah, go ahead.
Does it return, like, when you try to add something that's already there, will it return a value so that you can see that it was already there?
Let me see. Let's go to the documentation. Java set. I believe that it might be a Boolean, but I can't remember for sure. Add. All right. There you go. It returns a Boolean. It adds a specified element to the set that if it is not already present. Optional operation, you need to go to the full documentation to get what the return type is. It returns true if the set did not already contain the specified element. Returns false if it already contained it. So let me go back to the code and show you what I mean by that. But to show you what I mean by that, I want to show you a preview of something that we're going to do. I'm going to go off to this blue area over here, and I'm going to set what's called a breakpoint. You're probably familiar with this when you use GDB. A breakpoint is a point at which you can run a debugger. It'll run the program up to that point and then pause and let you take a look at the running program. Because if I just ran this, it would run by in a millisecond and we would never even see it. How do you run the debugger in Eclipse? Well, there's this little bug up here, right? Right next to the play button, there's a bug that you can go ahead and hit. And it'll say, do you want to switch context? And yes, I do, because over here on the right, it's going to print everything for me. So let me go ahead and step through this. Up here, you have continue. You have stop the entire program. You can step into a function if you want to do that, or you can step over the next line. So I'm going to go ahead and step through this, right? And things are changing over here. You don't necessarily see that they're changing unless you highlight something. Once you highlight it, here's the set so far. After running through line 31, it contains 20 and 10, and they were not necessarily added in that order. When I go to the next line, okay, there's 30. When I go to the next line, okay, there's 40. Print it out, and it appears down in the console, but the set is otherwise unchanged. When I go ahead and go to the next line, I didn't have a variable capture the return type, so let me go ahead and do that now. Boolean foo is equal to. Save that. Now it's going to I changed the code, so it's going to give me an option. Well, do you want to continue with the old code, or do you want to relaunch it? And so I'll go ahead and restart it. Right? And I don't want to have to hit continue, 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 continue. You can always set another dynamic breakpoint over here. It's not going to show up because there's a warning there that foo is not used. But I will go ahead and continue to that breakpoint. You notice that it went through everything immediately, and it jumped down here automatically. When I go to the next line here, I do see foo over here, and it's false. It's false because it did not add 30 because 30 was already in there. Right? So that's one way. Otherwise, if you wanted, if I had done a poor man's debugger version of this, I would have captured that variable and printed it out. And that's a poor person's way of doing things, right? You have a nice debugger. Use the debugger, right? And there are lots of other things that you can do. You can set conditional breakpoints. Basically, anything that you did with GDB, you can do with this, but it's a nice little graphical interface instead of a TUI, a text-based user interface that we use with GDB. Right? Let me go ahead and get out of this. Now, you will need to get back to your coding environment. You can go ahead and make changes to this and save it, but if you want to, your perspectives are all up here in the top right. I'm going to go ahead and go back to my Java perspective so I can see what I'm doing traditionally. You can always go back to the debugging perspective if you want, but I prefer the Java perspective here. If you want to, you can add another perspective. There are lots of different perspectives. You probably looked at the Git perspective when you were doing Lab 1, when you checked it out initially. And there are a bunch of other perspectives here that you can look at that basically just change the layout so that you're changing context, you're doing something else other than just coding. Right? There. Right? Again, the third and last dynamic data structure that I want to show you is that it also supports maps. Java has a nice map implementation, right? Using a hash map. Right? So what is a map? A map allows you to map arbitrary objects. arbitrary objects to other arbitrary objects. Right? Now let's think about this for a second. With an array or with a list, you're mapping things to other things. You're mapping 0 to the first one. You're mapping 1 to the second one. You're mapping 2 to the third one, etc. But your map is very limited. You're only mapping integers to whatever you're putting into your array. Not only that, but you are limited to 0, 1, 2, 3. In other words, it has to start at 0. It has to be contiguous. But with a map, you can do whatever you want. Let me go ahead and get rid of this and show you. Right. So I'm going to create a map. Let me go ahead and map integers to strings. Right. We don't pluralize. But there's that langle-wrangle again, but I put 2 things in there with a comma between them. That's because I'm saying that I'm going to map integers to strings. Right? And I'll just put in m for my, or let's go my map. There we go. Is equal to new hash map of integer to string. And by the way, if you want modern Java, you can use elision again. You don't have to provide the second parameterization if you're using Java 8 or above. So I'll go ahead and shorten it up like that, knowing that it's integer to a string map. And again, it hasn't been imported, so let me go ahead and import those. All right, there we go. Now, I don't just willy-nilly add whatever I want, right? Instead, I need to say this thing maps to this thing over here. I can go ahead and say my map.put. I'm not adding things. I'm putting things in the map. I'm mapping this thing to this thing over here. Let's go ahead and put 10 to Chris. There we go. Let's go ahead and put 20 to Kyle. All right, there we go. All right. My map.put, let's put 30 and map that to, I don't know, Darren. There we go. I'm mapping numbers, in this case integers, to strings. Right? Let's go ahead and print this out. System.out.println my map. And run it. And you'll see that 20 is associated with Kyle, 10 is associated with Chris, 30 is associated with Darren. Again, it's not ordered. Right? It's not necessarily ordered that the first thing that I put in there is the first thing there. There are implementations that preserve order, insertion order or other orders if you want. The basic hash map doesn't do that though. So I can put stuff in, I can print it. How can I pull stuff out? Right? If I want my name, like string my name is equal to, I have to get it out of the map. My map.get. Right? Now, these are called keys and values. Keys map to values. So if I want that value, Chris, I need to have the key that maps to it. In this case, it's going to be 10. And when I print that out, I get the value that I'm looking for, my name. My name. There we go. There. Chris. Right? What happens if I get something that doesn't exist? We didn't map 40, did we? Right? What do you think it returns? There is no key 40, and it's not mapping anything. So what is nothing? Null, right? So it gives me back null. I can tell there are a whole bunch of methods that you can use. Contains key, contains value that goes through and says, yeah, that key exists, or no, that key does not exist, or that value exists, no, it doesn't exist. What do you have to do? You have to RTM. You have to read the manual. So you just have to pull up Google, look at the documentation for a map, and you can see what's going on there. Now, I didn't start at 0, 1, 2, 3. It was not contiguous. I skipped 0 through 9. I skipped 11 through 19, right? So it's not the same thing as an array or a list. I can map arbitrary objects to other arbitrary objects. And it doesn't have to be an integer either. Let me go ahead and go with a separate map, my other map, say. And instead of going from an integer to a string, I'll go from a string to an integer. Right? I'll go in the reverse order. Or I can go ahead and map a string to a string. Right? What would be the use case here? Maybe I could map a full name to a nickname. My other map, or map dot put Christopher maps to Chris. Right? My other map dot put Joseph maps to Joe. There we go. And then now what's my key? My key now is Christopher instead. And then I can get that get the value out, Chris, by searching for that key. Right? It's basically a complete abstraction of what you've been doing with arrays. Now you're no longer bounded by the size of the data structure, because it'll grow and shrink as it needs. You're no longer bound by using contiguous integers for your keys. You can use arbitrary objects for your keys. Yeah. That would be incompatible, right? Because one of them is mapping integers to strings, and the other one is mapping strings to strings. If I tried to do that, let's say my other map dot add all my map, compiler error, right? And you can't see it here because it's too small, but the method add all is undefined for the string because it's expecting a integer to a string, and that's not an integer it's expecting a string to string, and you're giving it an integer to a string. Just like if you tried to do this with a parameterized list, if you made a list for integers and tried to add a string to it, compiler error, right? You can't do that. No, you have to provide a key and a value, right? You can't just provide a value or a key. You can do something like this. My map dot put. You can map null to null. Not very useful though. You can map null to null. Right? You can map something that's null to not null, and the other way around. You can map foo to null. But again, those are not that useful, right? Another question over here? No? Okay.
Wondering about iteration, like if you do an enhanced loop.
Good question. How do we, if we need to process each one of those key value pairs, here's how you can do it. For, again, an enhanced for loop here. Now, let me go ahead and iterate over my other map here, which is a string to a string. I want to map, there are a couple of ways that you can do this. The easiest way that I like doing is, let's iterate over all the keys for each key. And I'll put that up here in comments. For each key, right? So for each string value, s, in the collection, my other map. Now, that's not a collection of strings. It's a mapping of strings to other strings. So how do I just get the keys? There is a nice key set method that returns a set of all the keys to you. So now I'm iterating over all of the keys, and I can go ahead and use the get method, my other map dot get on s, right? And I'll go ahead and say system.out.println. I will say that this thing s dot maps to plus, and then that other thing. And balanced. There we go. Christopher maps to Chris. Joseph maps to Joe. Right? So that's how I would normally do it. There is a way that you can do it with both key value pairs. It's an entry set, but it just gives you a new object that represents a key and a value. Then you still have to extract the key. You still have to extract the value. And it's not as elegant, I think. Right? And then there are other modern ways of doing it with Java 11 or whatever. Whenever they introduce streams, Java 8, I guess, when they introduce streams, there are other ways of doing it as well. Right? Okay.
Could you map something to another map?
Yep. Just like you can have a set of integers. Oh, what is that? All right. It's a set of integers. Right. So I could say s.add new set, hash set of whatever. I could add, do I already have a set of integers? No, I don't. But you get the idea. You can have a list of lists of strings. You can have a map of a map, the integer to string, and then that map itself maps to a, I don't know, string, whatever, right? STU, right? So you can pretty much do whatever you want. You can go down that rabbit hole as far as you want. I would suggest that you don't do that. Keep it simple, right? 2 levels deep, it might have some use cases. For example, in 235, if you generate a power set, that's a set of sets. If you want to go down 3 levels, 4 levels, rethink what you're doing, right? Just like when you have multidimensional arrays. I'm not going to go over multidimensional arrays, but you can use them in Java. If you find yourself going 1 dimension, great. If you find yourself going 2 dimensions, great. That's fine too. That's a table. That's tabular data. That is matrix data. Fine. But if you find yourself going 3 dimensions, 4 dimensions, 5 dimensions, probably rethink that design. Because you could probably define, say in C, you could define a structure to hold all that data. In Java, you're going to probably want to define a class instead. Okay? But yeah, you can do this. Let me go ahead and cut and paste this so that we've got it in our notes. All right? There we go. All right. All right. Any questions so far? Otherwise, a little bit more on strings. So Java provides a huge library, standard library of methods to compute compute various things about strings. All right? And for details, RTM. Right? RTM again is read the manual. Let me go ahead and go over here, Java string. Let's search for it. Let me go ahead and bring this up. And it's zoomed in enough here. But look at let's not zoom so much. There we go. Otherwise, it's difficult to read. Look at all of the methods that you have. You have an entire scroll of methods here that you can use. You can get an individual character if you want. So if you want to, it's 0 index. So if you want the first character, it'll give it to you. Second character, third character. There are no null terminating characters, so you do have to use length. How do I know how long a string is? Well, there we go. There's a length method that'll tell me that. If I want to take a substring, say I've got a big string and I want to take a substring from here over to here, well, there's a substring method. In fact, there are 2 substring methods. One where you can begin at a particular index and then it'll give you a new string all the way to the end of the old string. You can go from one index to another index. I just want this part of this larger string over here. So you can use a substring starting here and ending here, -1. Give me that string. Right? So there are lots of things that you can do. You can convert it to lowercase. You can convert it to uppercase. You can replace strings. So if you've got a string and you have a character and you want to replace that, a capital O, and you want to change that to a lowercase o, you can do all of that stuff. The key thing to remember is, after you've RTM'd and see, is there something here that will help me? The key thing to remember is that strings are immutable. Right? And I think I might have shown this before, but let's go ahead and review it. String s is equal to hello. Right? I want to change that all to uppercase. S dot to uppercase, right, is a function that'll let you do that. Let me go ahead and print it out. System.out.println s. Right? Now, what's it going to print? What do I want it to print? All uppercase HELLO, right? But it's not going to print that. It's going to print all lowercase HELLO. That's because I did not change this string. S is unchanged. What this function is doing, what this method is doing, is actually returning a new string with the contents uppercase HELLO. Right? If I captured that, there's the return type right there, string. It returns a new string. If I capture that into a string, T, and I print that out, I will see that, in fact, T is a new string with different contents. Now it is uppercase HELLO. All of the methods do this. There's not a single method there that will change a string because it's immutable. Once created, it cannot be changed. Right? It can be destroyed. It can be reassigned. Right? I could say reassign. Instead of doing something like this, I could have said, well, now S is going to be S is equal to whatever that is. That's getting rid of the old one and reassigning basically S is a pointer. It's a reference. Before it was pointing to lowercase HELLO. And then by calling that, here's a new string, uppercase HELLO. And by reassigning that, I'm saying S no longer points to this one up here. S now points to this one down here. Right? And then this one is now eligible for garbage collection and is taken care of for me by the Java virtual machine. So keep that in mind. You cannot change a string. Okay? But keep in mind, strings are immutable. Well, okay, you really want immutable strings. You really want a string that you can change, right? If you really want a string that you can change, use string builder, right? There's also string buffer, but I find it less useful. String builder is very, very nice, right? String builder looks something like this. Instead of a string, is equal to, equal to new string builder. You can build a string if you want, right? And I need to string builder, SB, right? You can build a brand new string if you want. SB.append, right? Hello, right? SB.append, space, SB.append, world. There we go. Oh, you know what? I wanted to add my name in the beginning. I could go up here and append it first, or I could go SB dot, isn't there dot prepend? What is it? Append, where is it? Off the top of my head, I forget. Scroll. Insert. So insert at 0. Nebraska, I don't know. I'm running out of thing. Foo, I guess it would be the go-to. And now let's go ahead and print this out and see what it looks like. String dot, system dot out dot println SB, right? Print it out. And now Nebraska was prepended, right? I don't know why they don't have prepend. That would make sense to me. If they've got append, they should have the other prepend. But instead, it's called insert. You can insert arbitrary strings. It shoves it out and makes room for it. It changes the string, right? I could go ahead and convert them all to uppercase. SB.to, dot replace. There we go. I'll replace Nebraska with, I don't want to replace Nebraska, do I? Replace starting at 0 up to, so I have to do some manual calculations here. 0, 1, 2, 3, 4, 5, 6, 7. 7, replace it with, I don't know, what would you replace Nebraska with? Indiana? I'm just saying that because that's who we played last night, right? Because I'm not printing it out again, right? But we won, so we should be replacing Indiana with Nebraska. And I was off by 1 there. I need to go all the way up to 8. There. And it ends up changing that string, right? So you can do whatever you want with a string builder. You just can't do whatever you want with a string. But if you want to take a string builder and dump it to a regular old string, you can do that. Final result is equal to SB.toString. And now when I print out final result, I get that final result, but now it's an immutable string. I can't change that. I can't go back and now change Indiana back to Nebraska anymore because that's a string. The string builder, SB, is still mutable, and I can go ahead and play around with that and continue playing around with that as much as I want. But the string final result is not mutable, right? It's been dumped to a regular old string. It is fixed until it is cleaned up or at the end of your program is cleaned up, right? So here's an example, right? There we go. I'll put that into the notes as well. Let's see. Oh, we're good on time. What's next? Methods. Then we'll talk about file I/O if we have time. All right? So in Java, functions are technically called methods. Don't worry about it. It's just a pedantic nomenclature. Some people also call them procedures or sub-procedures or routines or subroutines or whatever. It doesn't matter. The technical definition is that once a function belongs to a class, it becomes a method. It's just slightly different, so we have to call it something different, right? Because we need to write papers on computer language theory. We need labels to label stuff so that we know what we're talking about. But unless you're going to get into arcane language development, like computer programming language development, it doesn't matter. You'll find me calling them functions sometime. You'll find me calling them methods sometimes, or accidentally correcting myself into methods. It doesn't matter, right? In Java, however, one aspect of it is that every method must belong to some class. Now, this is in contrast to, say, a lot of other programming languages, even object-oriented programming languages like C++, non-object-oriented programming languages like C. Functions, where do they live? They live at the global scope or in some module somewhere. They're not part of a class because in C you don't have classes. In C++, they can be outside of a class or inside of a class. With Python, they can be inside of a class or they could be outside of a class, I believe. Yeah, you can declare global functions in Python. But in Java, they have to belong to some class, right? For now, we will make all of our methods static, right? Until we get into object-oriented programming a little bit more, meaning that the method will belong to the class itself. Right? When it's non-static, that means it belongs to instances of the class. Like when I create a string, right, and I create a string s and I go s dot, I start to access its member methods. Whereas if I went with the class name itself, then dot, then I would be calling a static method. Let me show you an example. So let's see, right? I'm going to show you how to use static methods. I want to do the square root function, right? Int, or it's not int, let's say double x is equal to 2.0. I want the square root of 2. Well, first of all, where do you think the math functions are? In the math library, math.sqrt, right, of x. And let me capture that. Double y is equal to this. And oops, there we go. And then system.out.println y. There we go. Let me go ahead and create that. Now, did I create a math thing, right? Like I did with a string s is equal to this, or a list. My list is equal to a new list, right? No, I didn't. Instead, I simply just called math.squareroot. And that's because it's a static method. SQRT belongs to the math class. And therefore, I don't have to create a thing before I can use it, right? That's what a static method is. By the way, there's a lot more stuff. If not just square root, what else do you think is in there? Sine, or not sine, but sin, right? Cosine, cos. Tangent, right? Arctangent, a cosine, arc cosine, et cetera, all that kind of stuff is there, right? They all act in radians, so if I go with sine of 3.14159, what's sine of pi, or approximately pi? Yeah, this is very, very small because I didn't go out enough digits. Well, that's OK, because if I want pi all the way out to so many digits, math.pi is there for me, right? Other constants include e, 2.1711, whatever, math.pi. Now it should be extremely close to 0, if not 0. OK, it's not. It's very, very close to 0, right? It basically has some lower order terms that are not exact there. This is e minus 16. It's a very, very small number. It's as close to 0 as you can get without actually being there, right? But this is a static method. So you access static methods. You can access, in other words, run or execute static methods using the class name plus a dot plus the method name. Right? You can declare static methods using the static keyword. And you've been doing this the entire time. Anytime you create a main, what is in main? Public static void main, and then whatever you want to give it. Let me go ahead and create another method here. I don't know, let's do the go-to usually is Euclidean distance, right? So public static, it's no longer void, right? This is the return type, double Euclidean distance, right? Of double x, double, or x1, double y1, double y2, or x2, sorry, double y2. There we go. And it's not going to fit, darn it. That's all right. Let me go ahead and make it bigger, or you know what? I'm just going to go down to the next line so that it fits. Tab this over, or space it over. There we go. there's my first separate function declaration. I made it public. We'll talk about public here in a moment, but that basically means that anybody can see it, anybody can use your function. If you made it private, that means that only your class itself, like this class that I called Hello World, can use it. I made it static so that it belongs to the class so that you can use it by calling hello world dot Euclidean distance. It returns a double. Its name is Euclidean distance, and it takes 4 parameters, all doubles. So remind me of the distance formula. How do I compute the distance between 2 points x1 and x1, y1, x2, y2? Square root, math dot square root. Right? And what? x1 minus x2, right? Squared. Something like this. Uh-oh. You can't do that in Java, can you? Nope. It's the caret, I believe, is the bitwise exclusive OR operator. So that's not going to work. Instead, how do I do power? Yeah, you could use math.pow, oops, if you want. There's the base, and then the exponent is going to be 2. That'll work. Otherwise, what else could I have done? Oh, and it's plus. Instead, I could have gone y1 minus y2. And to square that, what do you need to do? Just multiply it by itself, right? So there's the return value. I'll just simply return it immediately. And now all the compiler errors go away. And there's my first function. In fact, it's a function calling another function, right? Let me go ahead and actually use it up here. To invoke that function, again, it belongs to a class. In Java, everything is a class or belongs to a class. This function here belongs to the hello world class. So I need to invoke it by calling hello world dot Euclidean distance. Right? And then, I don't know, 0, 0, up to 2, 2. Right? How big is that going to be? Oh, here. Let's just go to 1, 1. Why 1, 1? It'll be square root of 2, right? So let's capture that value, w, or I've already declared y. So y is equal to, there we go, and print it out, and execute it. There we go. That's the square root of 2 right there, because going from 0, 0 up to 1, 1, well, this is a square root of 1, 1, right? Add those, square those and add those together, you get 2. So the hypotenuse, square root of that. But that's how you can build your own functions. It's going to be public for now, static for now, and then the return type, the name of the function, and then any parameters that you want to give it. If you're coming from a C background, you might remember that we had prototypes in a separate file and implementations in a source file. We don't do that here. It's all in one place. Okay? There's only one declaration and definition in a class. And I can I can have the we'll get into it later, but you can have functions with the same name and different parameters. You can have functions with the same name in different classes. As long as I've got Hello World 1 and Hello World 2, I can put the same functions in there if I really want to. Not a good idea because you're duplicating things and violating the DRY principle, don't repeat yourself principle. So make sure that you are organizing your functions in, where they should be. Another aspect of functions, when you declare a function, it's best to document them. And again, we've got nice little Java doc style comments here. You can say that computes the Euclidean distance between 2 points, let's say x1, y1, and x2, y2, right? And it's, unfortunately, you're not going to be able to see it very well, but you'll see that it formats it very nicely over here. But if I want to format it further, I want to format this, say, italicized, or I'm going to go ahead and format it as code, end code, right? Let me go ahead and italicize this one to show you the variety here. Right? I is just, that's just HTML for italicize. It's bad HTML, but it's historic HTML. You'll see right here that it's italicized. Over here, it's in a monospaced font, making it look like code, right? So you can mark things up. You can document individual parameters, the x coordinate of the first point, right? This is getting kind of ridiculous because this is really verbose. But if you were writing a very popular library that was going to be used by millions of people, you'd want good documentation, like the Java standard library has. But you can go. The return value here is going to be, I don't know, the Euclidean distance between them. Okay? And again, it formats it all like this, so that when you go to actually produce your documentation, it looks like this, right? If you wanted to produce documentation. You just have to run javadoc. It runs through, grabs all your javadocs, and produces HTML files that then you can deploy along with your library if you're writing a library. Okay? That's javadoc style comments. Let me go ahead and copy this so that you have it in your notes. We will come back to methods later on when we talk about member methods, but for now, don't worry about it. Especially for your first assignment, you're going to want to make all of your methods static. Okay? If you want to, you can go ahead and start making classes and having functions in your classes, but there's no reason to on simple stuff like your first assignment. Actually, I take that back. You would actually be helped if you wrote, say, a game object for that third exercise. Okay. All right. All right. Input output. Let me go ahead and cut and paste this since we've already reviewed it. You can go with a standard output, which is java.out, and then you can use printf, you can use println, you can use print, and a whole bunch of other things. Forget about PHP. Sorry. You can use placeholders, %d, %f, %s for integers, doubles, and respectively. You have escape characters. So to get an endline, \n, R is a carriage return. There is a difference. The difference is historic. What's the difference between an endline and a carriage return? You have to think back to typewriters. If you just simply turn the drum, that just goes down. But the cursor, the current spot in the page would still be in the same spot. It's only when you go down and then go back to the beginning of the line is that a new line. And so we still have, because we had typewriters even back in the 50s and even up to the 80s, even word processors in the 80s, we still have that historic distinction, even though it's kind of archaic now. Get a tab character. How do you get the / character itself? //, right? So you can use those in standard output. You can also have standard input, right? So if standard output is in system.out, where do you think standard input is? Use system.in, right? So I'm going to show you how to do that now. I'm going to come over here and let's go ahead and get rid of all this stuff so that we're not confused. There we go. I'll go ahead and get rid of this as well. So how do I read an input from the user? Let me go ahead and prompt the user for an input. Println. Enter a number, please. We'll be polite about it. All right. Oops. Sorry. Can't type today. There we go. And good. All right. So if I just ran this, of course, it would just prompt the user and end, right? You see over here that there is no stop button because the program ended. What I actually want to do is I want to read it in from the user. The easiest way to do this is to use what's called a scanner. S is equal to new scanner. Right? Now, scanners can scan anything. Scanners can scan a file. Now, this is how we're going to do file input. A scanner can scan an individual string. A scanner can scan whatever you give it. I want it to scan from the standard input. So I'm going to give it the standard input, system.in. Right? And I have to import it. It's in the utils library. And now I've got a scanner that's scanning the standard input. In other words, me mashing the keyboard. We're going to go ahead and expect them to enter in a number. Int x is equal to an integer. And so let's change the instructions here to an integer. There we go. S.next int. Int. There we go. What if we wanted to prompt them instead for a string? Enter a name. Name, please. Well, then I would be reading in a string, right? And so I would go s dot. Oh, if I get an integer in next int, then what's get the next string? Unfortunately, it's not next string. It's next. Just next. That's the default. If I wanted to do a double, it would be next double, right? That's you can read in a floating point number. You can basically read in any type from the user. Let me go ahead and revert this back to next int, right? And then let's go ahead and print system.out.println red plus x plus and plus name. Right? So let's go ahead and run this. It'll prompt me to enter an integer. Now, in the command, in the console, to get actually down here to the console to start typing, you have to actually change your focus down here. So you have to click down here. Now you see the cursor blinking. Otherwise, if I'm up here and I start typing, I'm not typing down in the terminal. Undo that. I need to go down here and start typing. So 10. All right. Enter. Enter says, OK, go ahead and read what I typed. Oh, now please enter a name. My name, Chris. Enter. I read 10 in Chris. Right? There's no scanf or anything like that. There's no pass-by reference if you're coming from a C background. It's just simply, here's a scanner. It can scan for whatever you want. Right? Now, that doesn't stop an ID10T user from mashing the keyboard. Please enter an integer. OK. 10. Right? Now, obviously, it meant please enter a number. What's going to happen here? This is another big difference between, say, C and Java. If this were C, it would, T, that's not a number. So what have I read so far? 0. All right, 0. Right? Here, it throws an exception. Let me go ahead and focus on this. The way that Java does error handling is through exceptions. And we'll learn how to write exceptions, use exceptions, and work with exceptions later on, probably on Thursday. But for now, what type of exception is this? Input mismatch exception. You asked them for an integer, you expected them to enter in an integer, and they didn't. They mashed the keyboard and gave you TEN instead. So it's going to throw an exception that this didn't work, right? And in this case, it was fatal to the program because I wasn't catching this exception and handling it. I wasn't doing any error handling here. I was just saying, okay, well, let the errors flow as they may. And when that happens, then it kills the entire program. Right? We'll, again, look at how to deal with that later. Let me go ahead and there is no error when if I mash the keyboard on a string, right? I can mash the keyboard as much as I want. That's also another contrast to C. If I did something like this, I would risk what? Overflow. I would risk a buffer overflow because I've got a string that holds 100 characters. I mash the keyboard and provide 1,000 characters. You're trying to take 1,000 characters and fit it into a string of size 100. That's not going to work. But this is Java, where everything is dynamic. Fine, you can go ahead and put that much in. I'll go ahead and read that in for you and make a string that's big enough to accommodate it. Right? And you'll see that all the way to the end there. Right? So, scanner is how you can read standard input. Well, it's also how you do file I/O. Right? So, sorry, let me go ahead and grab this so that you can have it for an example in the notes. Java. Here's an example of, and then we've done plenty of file output. We don't need another example of that one. How do we do file I/O? Right? Well, file input. Use a scanner. Right? Once you use a scanner, everything becomes really, really, really simple. Okay. Yep, we've got just enough time to show an example. So let me go ahead and open up a file. Let's go scanner s is equal to new scanner. Now instead of the standard input system.in, I'm going to want to read from a file. The way that you can create a new file is simply new file. And in this, you provide a string on where you can find that file. Now everything is going to be relative not to the system, but to my project. So what I'm going to do is I'm also going to show you how to integrate some data into your project. Here's my project Hello World. I'm going to create a folder in there, new folder, right? And I'll just call it data because that's what you're going to call it in your project. Then I'm going to create a new generic file in there, hello.txt. Right? And I can go ahead and edit that as much as I want. This is the first line. This is actually the third. This is the last. There we go. That's just a plain old text file. I want my scanner to read from that text file. Now it's going to be in data / and I called it hello.txt. Oops, that should be a slash. Right? There. If I just put in hello.txt, it's going to get confused and it's going to think, oh, you mean the text file that's directly in the source file or the build file. and that's not where it is. It's actually if you start putting data files into the same folder, into the same directories as your source files or your build files, you're going to start. That's disorganization. Don't do that. So I want to open it up in data, and then I want to open up the file hello.txt. Let me go ahead and import that. Now it's going to still complain about this. I'll show you why. Because it actually throws an exception. That's, again, how we do error handling. If that file doesn't exist, it's going to throw a file not found exception. Yeah, file not found exception. So it's asking me, well, do you want to resolve this in one of two ways? And we'll talk about why it does this later on Thursday. But I'm going to go ahead and surround it with a try catch. Okay? Don't worry about this for now. Right? Just worry about lines 29 through whatever we're going to do here. I've now got that. I'm going to assume that file was successfully opened. I'm going to read line by line, s dot next line. Right? Otherwise, I could have read the first word. I could have read the first character. I could have read the first number if there were numbers in there. There aren't. I'm going to go ahead and get the first line and capture that. String line is equal to this. And then let's go ahead and print it out. System.out.println line. And then we'll do it over and over again. Line is going to be equal to s.nextLine, right? And print that out. So how many lines did I have? I think 5. 1, 2, 3, 4, 5. Right? And let's go ahead and run it. There we go. It works. Oops, sorry. Console. So this is the first line. The second line was blank, right? And it read it, and it printed it out. This is actually the third. This is another blank line, and then this is the last. Right? That looks like some really terrible code because it's always going to assume that there are 5 lines. I've got copy pasta, right? Anytime you have copy pasta, you have spaghetti code. Don't do that. So instead, I want to read every single line all the way from the start of the file all the way to the end of the file. The scanner also provides, let's string line. The scanner also provides a way to determine whether or not you're at the end of the file. If this were C, you would be checking for EOF, end of file, right? When you read that special character, then you know that you're done. Or maybe if you're using forgets, then it returns null or something like that. What I'm going to do is s.hasNextLine, or simply hasNext, if it has anything to read left. So while S, the scanner, has another token to read, go ahead and read it and print it out. And I've already declared this, so I'll get rid of that and get rid of all this stuff now. That while loop will read all the way to the end of the file, line by line if I want, and print each one of those out. If I'm doing CSV data, comma-separated value data, I can read a line, then chop it up using a split method. Right? Do I still have the strings up there? Yeah. How do I chop it up, like string tokenization? There's a nice split method that you can provide it a delimiter, which is a regular expression, or a comma, and it'll chop it up and give you all the tokens. Right? Let's see what time. With 2 minutes left, let me show you. Let me go over here to hello, and let's go ahead and this is CSV data. Wow. All right, there we go. Now let's go ahead and take that line and split it up. Tokens. It returns a string array is equal to line.split. Right? And I want to split it along commas. And I'll go ahead and print that system.out.println tokens. And here's one last trick. This is not going to work. We might get an exception after the first line. There. Well, no, it'll work. This is CSV data. Wow. Then it tried to split it up and print it out. It doesn't work because that's an array. How do I print an array? Arrays.toString of tokens. And let's go ahead and focus on that first line there. It should all be split out. This is CSV data. Wow. And it's comma delimited because it's in its own array. It's been split up based on that comma character right there. Right? So we'll go ahead and finish up on file IO next time.